Hello everybody and welcome to our LEDart review. The LEDart project by Evado was started in 2006 and well, this morning in 2012 I found a box in the shelf with the label LEDart prototypes, and that's what you can see here on the table. And now I want to give you a brief introduction of the evolution steps we had with our LEDart baby. It all started with a lumen strip. This is the lumen strip, the basic or the foundation component of the whole LEDart system. What you can see here is a frame embedding the LED PCB, and each PCB is covered by a tile. So you can use for the projects your individual material and your individual colors to bring the more technical looking LED display to architectural wall installation with an individual material component. As we figured out, the challenge was not the mechanics or the LED technology. The challenge here was the data, the signal processing. We started with this tiny board here. It's an ARM-based platform, an ARM microcontroller, and we found out, or we figured out, this is simply not powerful enough to bring all the information and to the display and to process all the information. This is a DSP platform combined with a FPGA. So we have the software running here and the distribution for the pixel information on this device, and we have parallel outputs like 6 channels or more to the LED. If it comes in an enclosure, looks like this. This is like a small box mounted behind the wall and controlled by a remote control or by a DMX signal. Also, you can bring your own video content through a USB interface, and we have another evado interface for configuration purpose and maintenance purpose. With this new platform, the DSP and FPGA based platform, we also changed the LED PCB, as you can see here, with much more parts on the rear side. We moved to a 48-volt infrastructure. Well, these are all technical informations, but that was the challenge here. The technique was the challenge. The idea here was quite simple. We have a framework, a faceplate, and a material, and a PCB. But we never thought that we are faced to technical issues by the control. So this control here is really good for controlling high density of pixels of LEDs. Like for example, here we have a RGB PCB from 2008, and this is good, or this control is good for this application because we don't have long cables or long wires. If it comes to large scale installations, we were faced to some problems. We fixed by the third stage. I mean, this is called the G2, generation number 2, and what you can see here is the generation 3, we call it K5 platform. This is Ethernet and TCP/IP based signal distribution or signal processing. So you can use long cables, long wires for large scale installations without any problems you have with this box here. So let me give you an idea how this K5 platform looks like. It looks like this here. This is cover. This is what we call motherboard, and underneath we have the module. That means one module is simply 16 of the strips, so that it comes to 16 over 16 LEDs, totally 256 LEDs. And with this K5 approach, we still have 48 volt infrastructure, and one K5 subcontroller is responsible for the number of 8 of these modules. So for 8 of the modules you need one subcontroller. Then we simply loop it from one module to the next module. And how all this works, I'm gonna show you with the next video.